Welcome to our Vision Campus. Today I would like to talk about the GigE Vision 2.0 standard and how multi-camera applications can take advantage of its functions. GigE, or Gigabit Ethernet, is one of the most common camera interfaces. The latest version of the GigE Vision standards expands the possibilities for the GigE interface. GigE Vision 2.0 allows multi-camera systems to be synchronized more precisely and run in real time. Applications that require synchronized image capturing between multiple cameras can range from 3D triangulation tasks to sports and motion analysis to monitoring applications for conveyor belts. Take soccer, for example. In many modern stadiums, there are several cameras that capture the soccer game from different angles. The different cameras all capture an image at exactly the same time. Those synchronized images then are put together into one 3D image. This gives you a 360-degree view of the game. It is a nice gimmick for soccer fans, but a handy analysis tool for the coach. One important component of the GigE Vision 2.0 standard is the IEEE 1588 Precision Time Protocol, or PTP. PTP is a network protocol to achieve precise time synchronization between multiple cameras within one network. For PTP to work within a network, it needs PTP-ready devices. In our example, we will have a closer look at PTP-compliant cameras. The PTP-compliant cameras first determine among themselves which of them has the most precise clock. PTP works with two types of clocks. One is the master clock, and the others operate as slaves. The master clock is ideally controlled by a GPS receiver. It can use that to synchronize to Coordinated Universal Time, or UTC time. The other cameras, the slaves, synchronize to the camera operating as master clock until they are all working with the same precise system time measured in nanoseconds. Imagine you want to record red light violations, and you want to do that using multiple cameras from different angles. One camera is located on top of the traffic light. It is triggered when a car passes the stop line after the lights have turned red. Another camera is located on the other side of the street. It captures an image at the same time to make sure if the car really passed the street or if it just went past the stop line. A precise timestamp allows you to assign the individual images to one another. That way, authorities can check whether there really was a violation and, if necessary, take enforcement action. Thanks to PTP, all cameras are working with the same system time. This means that all the individual cameras capture each image at the exact same time. Since the earliest stages in their development, GigE Vision cameras have been able to receive and react to what is known as action commands. An action command is an Ethernet packet that can be sent by a network client to multiple recipients on a network. The most important use case for the action command is triggering an image over the network. In the past, triggering multiple GigE cameras at the same time required a hardwired connection via the camera's digital I/O connector. A cable connected each individual camera to a trigger source. Imagine this at a soccer stadium. You would have to use hundreds of meters of cables throughout the entire stadium. Thanks to GigE Vision 2.0, you can now add a PTP timestamp to the action command to specify the exact system time at which the action command should be executed. This is called a scheduled action command. The scheduled action command helps to re-establish real-time behavior without using physical trigger lines. For our soccer example, this means that you don't need the hundreds of meters of trigger cables anymore. A common example from the machine vision world using scheduled action commands is semiconductor inspection. Semiconductors are transported on a conveyor belt at a uniform speed. They pass below a series of 4 cameras installed for inspection purposes. These cameras are positioned directly next to one another and vertically to the conveyor belt. Each camera captures an image of the semiconductors at the same precise moment as the semiconductor passes below the camera's location. Since the individual images will then be merged into one single image, it is important that the cameras really do acquire the image at precisely the same moment. The image is acquired in perfect sync, down to microseconds. Thanks to the GigE Vision 2.0 standard and PTP, multiple cameras within a vision system can be triggered with a single software command synchronously. You don't need an additional hardware trigger. This reduces the system costs as well as the complexity of the setup, especially with cameras using power over Ethernet. With GigE Vision 2.0, you can use a single cable solution as it combines 4 essential functions, namely power supply, control, image capture and synchronization. Thanks for watching.